All right, good afternoon, everybody. My name is Ryan. I'm a cybersecurity researcher, and this presentation is on some IoT device research that I've done a little while ago called Breaking the Grounds. It's, long story short, we'll get into it a little bit more, but it's basically research that covers like 5 different IoT devices, but this time we're going to be targeting one specifically called Roku. Uh, we'll just kind of dive into it. So, sorry about the animations, I forgot to make them static, my bad. Um, so this presentation is primarily about that research, and we'll be talking about what the research was, how I conducted it, and why I conducted it. Mostly, a lot of it was just problem solving, and I also talk about at the end here about some of the flaws I found in the devices that I was able to write in kind of like it wasn't an exploit because it wasn't a vulnerability, but an abuse script written out of my own programming language called the Skyline programming language. It's a personal programming language I wrote a while back for offensive security kind of operations, just because I didn't want to use Python and I'm a little bit uh, sketchy of it. But so moving forth, who am I? I kind of give you a base introduction, but a little bit of a more technical background. I'm an author of 3 different books: Black Hat Go, uh, Black Hat Python Manual, and Game Hacker Field Manual. The Black Hat Go is a manual as well, so Black Hat Go Manual, inspired by the original Black Hat Go book. And I'm an educator for guided hacking in a project called the Safer Internet Project, and a security analyst for a medical cannabis company called the Dr. Green NFC project. So not a company, but a project led by another cannabis company out in Portugal. And our goal is to revolutionize the cannabis industry by introducing medical alternatives and security safe, networking growth. So moving straight into the presentation, what is this research about? So this research was kind of just randomly conducted. I was working on a server-sided application, and I was using Wireshark to debug the network. And I found that one of the IoT devices on the network was broadcasting SSDP, Simple Service Discovery Protocol packets, that was just kind of broadcasting its endpoints, and I'll get into that a little bit more. But the research was also for skill verification. I had a few issues with my own skill where I was doubting myself, and I kind of felt that the research would give a good like pinpoint as to what I was doing, especially in different environments and stuff, kind of like a way to train myself a little bit more and make sure I'm confident in everything. So yeah, that's pretty much just a rundown of it. A lot of it was also experimentation with a custom programming language. At the time, I was also tuning the parameters and a whole bunch of other things behind the language because I'm like the only developer behind it and no one's maintaining it and it's proprietary. I had to keep it a little bit of a loner project, so no outside contribution. So a lot of maintenance work on my end. But yeah, so that's pretty much like what the research is about, breaking the grounds, because we're tackling IoT devices on the ground. Usually I have done like vehicles and stuff like that. I've done a little bit of aerospace, but kept it to mainly ground devices. So as mentioned, this research was done. I was exploring it by coincidence. I had done a little server notify routine here that, or I posted one, sorry, put an image here of Wireshark. This is a bunch of SSDP notify requests that are being sent out by a Roku device. Or actually, this here is an Amazon device on the network. Catching it was oddly by coincidence because for the server side tool, I was building a like kind of like a little credential capture, but specifically for a device that won't be talked about here for ethical reasons. But that's pretty much how it kind of just discovered it. It's just like in my eye vision, and I noticed, why is like an Amazon device just broadcasting a bunch of UUIDs and stuff and endpoints, especially without like any verification of who it's sending it to. It's just kind of randomly throwing it out there. So that's pretty much where it led me to finding it, and I started my research. So before we get into it, I figured I'd kind of list a little bit about like what goes into IoT devices. We're going to be picking them apart, so why not understand what goes into them? A lot of devices like Roku, Apple TV, Amazon Fire Sticks and stuff use a lot of proprietary network protocols, file formats, a whole wide range of other things that you have to reverse engineer or tackle to kind of understand the device a little bit more. In this research, I had to reverse engineer a proprietary file, not really proprietary, it's kind of half proprietary, half open, developed by Apple called the binary property list format that existed specifically for their Apple TVs and various other components. But they also had designs that fit specifically for IoT devices and kind of how to understand like how they work to interact with them, especially if you want to like automate tools. And another big thing is like custom protocols and error systems. Network protocols are a huge thing in IoT devices, and even though they're all built on the same network layer, or different network layers, but kind of the same structural implementation, it became a little bit of a task to reverse engineer it and go through some of the different protocols. In the case of Apple, someone's already reverse engineered their IoT protocols. They use Apple AirPlay. That's their real-time streaming protocols or audio protocols and stuff for streaming, over networks and stuff, and it's all built on their own framework. And you also see a lot of custom APIs, which is actually what we're going to be targeting today. Custom APIs were kind of the focal, point about this. We're kind of trying to attack it from a digital side, not really a physical, let's go break the hardware a little bit, because that's very expensive and it's hard to replace an Apple TV that's like $150 a box. But yeah, so custom APIs were a little bit cheap, faster, and easier to enumerate. And I kind of understood IoT devices anyway, at least for their API endpoints, because I've done previous experience testing APIs, especially in vehicle units or simulations and different vehicle head units and stuff like that. So yeah, that's pretty much just what goes into IoT devices, just for a basic, rundown of what we're going to be looking at. So the first thing was important. When I saw this, I was like, all right, I need to isolate it. So cool thing, I set up a cellular hotspot on my phone, and I isolated all devices by hooking them up to that hotspot, and I listened in on just specific IP addresses or different port ranges or things I was looking at through Wireshark to see if I could capture any routines. A lot of the times I was going to be like messing with a bunch of buttons, like what can this device do? What if I press the home button? What's going to happen over the network? Is it going to query MDNS or whatever it is out there? So eventually through that network, I kind of just kept that same isolation method because it was a lot easier and it's a lot better than noisier production home networks and stuff like that. So yeah, the isolation is pretty important, especially, noise cancellation and stuff helps a lot. So this research was primarily done about Roku. Roku, because they are the only one that won't sue me. It took a lot and a lot of debating to figure out whether or not this research was considered ethical, even before I conducted the research, because Apple is very, very strict as a company on their rules. I mean, even if you touch their device, it can be problematic, especially if you're posting about it. But Roku, however, was a little bit lenient. This is because instead of implementing like a flaw in their system that led to, say, an attacker being able to exploit it and then it being called unethical by Roku for me targeting it, they actually had a design flaw which was in their API systems but was rendered as an actual feature. However, I felt that throughout that feature it was a little bit of it was a design, or there were design flaws in the feature that allowed me to abuse it a lot more quicker. And we'll get to that a little bit shortly. But it was easier to navigate around. Heroku's a lot more of a fun device. They broadcast a lot of stuff. They're built really cheaply, and they're super super extremely easy to just rip open and replace. So if I brick it, I can just order one off of Amazon a little bit more cheaper, and it come the next day. As mentioned, I targeted many other devices: Chrome Stick, Fire Stick, Chrome TVs, a whole wide range of them, just to kind of mess around. All with the same targeting method. I did not change up my landscape a little bit. I just kind of kept on the same thing. Let's target APIs because those are going to be the most noisiest, most like broadcasted thing out there. Plus, a lot of people and developers will interact with APIs, so I felt it was a little bit better of a landscape than the target hardware, which is very minimal threat landscape, at least in the physical world. But yeah, so moving on. The first thing that I want to talk about is how I explored the APIs. Ideally, you can go on Google, you can search up APIs for Roku, and then you can get your documentation. Up until then, I didn't really notice that because I forgot the step of actually doing proper recon beforehand, and I was kind of rushing into it, so I didn't really follow my steps properly. But upon opening the SSDP routines, I know you guys can't see that, but there's a little bit of an IP address out there. It's an HTTP URL, and this is exactly the IP address that the device was dialing to. Now, the reason it was dialing is because it wanted to send broadcast information to other devices across the network. This is for Roku's collaboration methods and a whole bunch of other things that they wanted to do for their whole new system and stuff like that. Visiting this URL led me to a bunch of XML output, just standard API output that would be parsed by tools and stuff like that. It gave me a lot of information, such as file names like ECP and dial SCPD. Those are all, SCPD is pretty well known, but ECP there was a little bit weird because I've never seen that before in like an XML output. And I felt if it was like common enough, I'd probably see it. So the keywords here were ECP, SSPD, and UUID. The UUID is very important for a lot of reasons. A lot of IoT devices, especially Amazon, wouldn't let you access their URLs without that UUID. But of course, in the end, I built a tool that could just pull that out of the network and then just use it, which because it broadcasts it and doesn't check anything, it's just open for anyone to take. So yeah, that's pretty much the initial discovery there. A lot of information. You have a bunch of dial information for dialing services, SSDP setups, and a whole bunch of other standard stuff. Moving forward, we continued with passive recon after Googling ECP, which I should have done in the first place. I found across that they had ECP documentation, which is their external control protocol documentation. ECP by Roku, for those who aren't familiar with it, ECP was designed as a easy to connect RESTful API unit for Roku devices. Basically, anyone can make device query commands from like their app. So the purpose of it was to make like a mobile application that people could just like press buttons for like this digital remote and stuff like that, and it would set up sessions and stuff. Um, so I started exploring it a little bit more, went down the documentation. The top is blurred. There's a few things there that, as a result of throwing some Google queries at it, weren't really good to show, so I had to blur it out. But down here, we see that there's a lot of control events, pause play functions in the URL there. And there's also a unique URL here called query slash device information. Now, this was most important to me because I needed device information to query, protocols or packets, or if I was trying to remake SSDP requests, I would need, information for the device, at least for it to register. So in the bottom here, or at the actually top, bottom query, there says Roku developer program remote ECP commands and remote ECP comments, which gave me a little bit more information about the endpoints, and there was a little bit more developer forums. And I found out there was actually a way that you can query application information. So any device that had, like applications installed, it would tell you which ones were installed. And in this case, this XML output is exactly what it was. Now, the weird thing about this was I found that their APIs were kind of a little bit weird because you could just randomly just make a GET request and get this information, which isn't necessarily bad. I mean, devices need information to communicate. It's obviously, pretty normal, but the app information without authorization was a little bit weird. Like, why aren't we telling people what apps we've installed without, like, verifying who they are? Which kind of hinted me to go further. So after passive recon, I kind of wanted to collect everything, and I wanted to understand what I had here. And I had a little bit of a good file path going here, or server path, which is called query, which made query commands to the ECP server system that they had set up. And there was a query path that was used for the main ECP queries, and then device information to get device information, apps to get app info. Now, external control protocol ran on 8060, and it's also RESTful, so it's not stateful. It doesn't carry any state, which it will become problematic later on. And it does not seem to care who visits it at what endpoint. There are very specific things, such as developer mode, that you can't visit without it being enabled, but that's just standard device configuration and just standard development. So after this, I kind of moved on, and I was like, well, let's go ahead and let's Google Dark some more information. Let's see what we can find. And through here, I found a bunch of information about the SSDP setups, the protocol setups, the whole design, the structure of the packets, and all this that kind of gave me enough to craft it. Um, so yeah, ECP docs, I'm running out of time, so I kind of have to move a little bit more faster. So finally, I found out that there's key press, key up, and key down commands that you can send. I enumerated first by sending an empty post request to this URL, which then caused the command without any authentication or authorization methods to just completely execute the command. This, of course, was necessary. So this was, the testing method. This was the curl output 200, no errors here, just kind of null post, peacock, and then it just went home after that. And now it's time for madness. So it was pretty bad practice for it, and a lot of them they said it was a feature, but because the APIs don't require authorization, it's a little bit problematic for us. And we were going to cause madness by setting up a scenario where we could automate it across all like 10 different devices at once. So I took the design and I found a little bit of like a good automation script for it, like someone who already had kind of found it and walked through it, but this was just another developer who was using the API. And of course, this was the intended view. So this graph shows the initiation of the program, parse the command line arguments from the URL. Of course, it has to be 8060. That's checked. And it checks for different different queries and device information, different key presses and stuff like that to actually verify that it happens. But of course, this is how developers would use it. Initiate a program, send a request, and then of course it would go back. Nothing bad about that, right? Just enter an IP address, and then just device gets sent. And keep in mind, everything on here was local, so that is the thing. That was pretty cool. So you could sign on to any network, and pretty much as long as you had the IP address of the device, that was it. Now, here is my view. A little bit more complex. Sorry about the things. Didn't know it was going to come out a little bit weird like that. Long story short, my idea was to abuse this. Now, the first start of the tool would start an address resolution protocol module. It would scan all the devices on the network for all Roku devices, purely scanning their original, OUIs for information about them. If it was Roku, it would continue to target it and kind of load the information. Now, it would go through each and every single host on that network, and it would start them on a separate thread. This separate thread would format the URL endpoints and a few other things to make sure that all the information was correct before sending the request. And after all that information was set, it would take a JSON file of different key presses and all these different commands that you could send, and it would take that file and replicate it across like 20 different devices all at the same time. So because of how fast this was, and that the APIs weren't built correctly, you can DOS the device a little bit. You can do it very, very quickly if you do it enough. But long story short, the issue was that you could mass automate it. It was super fast and super easy to just go tell someone's device to go home. So that's pretty much a rundown of what it was, and I built a tool called Skyku. It's written out of the Skyline programming language, my proprietary programming language. Haven't released it yet, so on GitHub it's not really a fully runnable tool. I do have one called Caster that's written in the Go programming language, which is kind of like the very first base version of that, where I did all my research and stuff like that. But long story short, same thing. It just scans the network. It uses network ranges, throws out the device name, and then once you enter a command like tell the device to go home, it'll just go straight home. And I thought that was a really cool implementation of it, just pretty much a fast automation. And there were other options that would allow you to target all devices at the same time, as mentioned. And yeah, that's pretty much the end of the tool here that I built, which honestly it was pretty good because it was portable and it was easy to use in environments. But it's really only usable if you're doing black hat stuff, which you shouldn't be. Not recommended. So this brought us to what? Um, the developers were a little bit lazy with the design, and I thought that because they didn't care much about the user session perspective, that it was like, what are you doing here? Because now you're just setting up like a local server on a device and just letting anyone query to it, which is bad for numerous reasons, especially in the case that there's a vulnerability in the device that can be targeted by that. So we want to address that a little bit. They tried to be different by implementing something that was easy and quick and simple, but of course the issue reigns that, well, uh, they didn't realize that the annoyance factor was there, that you could have used that endpoint, and that's another problem. So what can like Roku learn from this? Implement sessions, verify users. I mean, verified addresses, maybe set up coins and tokens and a whole bunch of other things that could have protected them from doing this. And that's pretty much just a good takeaway. Always make sure you put security in mind when you're designing applications, because that's like the core problem of a lot of our issues today. So the other ideas explored by the end of this research, when I finished this research had kind of answered a question that was very topical for me. I had contemplated leaving the automotive cybersecurity world because I'd come to thought that it was a little bit financially unstable, and that field isn't really financed a lot more like stuff like web security is. So it gave me a good understanding of like the financial landscape, the root of the problems, and a whole bunch of other things that spawned from that. And we'll start from the threat landscape. IoT devices, especially like automotive technologies, this research kind of made me realize where a lot of the threat is. A lot of the threat, sadly, is not in a lot of these devices, because even though we can query, information, there's not a much an attacker can do with that until there's something exposed with that. So attackers are going to go for more something that's worth it. And even if they were to target something like automobiles or IoT devices, is the legal concern really worth it for them? Versus just like hijacking a car, for example. You would probably get, less time spent, or an attacker would get less time in prison for that than just hacking the device and breaking into servers and a whole bunch of other things that it takes to truly jack a car. And the same thing happens with IoT devices here, is by the time someone attacks it, even physically, it's like, is there really a full threat here outside of the physical appearance? And even then, how many people are actually going to be targeting that? Which might be why they didn't have security designed in mind. Even though security is still an important thing to think, I think the developers just were like, there's not really a threat here, especially if there's no open vulnerability, so let's just throw it out there, even though that's bad practice. It also gave me an interesting, is like IoT an ideal position to make a living off of? It's very possible to make a living off of IoT. A lot of people do it, but it's very expensive to get into the nitty gritty details, especially if you're not used to testing. Hardware, all that stuff is very expensive. And of course, is there funding? There's a lot of funding in IoT devices, medical research, and a whole bunch of other things that go behind it, but it's kind of falling on the landslide because of the way businesses operate. And the automotive industry is a good example of this, even though it's a very important field. corporations are really the only ones that have the funding to put into vehicle labs, which can cost millions of dollars to fund, especially if you have to build Faraday cages or a whole bunch of other things that you need for safety protection mechanisms and stuff. Of course, finally, the root of the problem. I realized that further on, the root of the problems of a lot of our security vulnerabilities is all in the design implementation. A lot of our networking protocols that you see in IoT, even Bluetooth, and even Apple's AirPlay protocols are all built on standards from like the 90s and the early 2000s when security wasn't even thought of as design. When this is a problem, or when we're at the root of it, it takes one little vulnerability in that root, and we saw this with Apple, but one vulnerability in that root for it all to collapse. And if you guys didn't know, Apple had a recent issue with their M2 chips because their design was bad, and that caused millions. I think it was about like a few. Sorry, I can't over exaggerate and say a few million, but I think at least a couple thousand devices to be. Oh, jeez, I didn't know that was. Okay. Yeah, it caused a few devices to kind of go a little bit insecure, so or unsecured. So the final thing, this was a little bit of a question I had for myself because it determined whether or not I was going to leave the automotive cybersecurity world. Is IoT for security important? It's very important. I mean, we can already say that any form of security is very, very important. But a lot of people also like to choose to focus on different fields that might end them in a worser loop. One thing I realized, or sorry, a more worse loop. One thing I realized with IoT is that it's also very hard to get into. The funding is one part, but then the technologies are another thing. If you don't know what system to pen test and you don't know where to start, then it's kind of hard to make a decision as to what you want to do. And if you're new, you're going to break a lot of things. So unless you have that money, it again becomes a problem. So for starters, it was a little bit of a focus that it is not really recommended. I wouldn't suggest, at least from my point of view. And at the end of the day, a system is a system. Another thing IoT, this research made me realize, uh, all of these systems are just physical systems that we hack every day. If you're a web pen tester, you can literally do the same thing. It's just the physical devices there, and all it's just contained into this little box. Finally, or the last two thing I said overcomplicated, but I skipped that because that's kind of just merging with the first one. Zero trust is not worth wasting your time perfecting because you can't. This is something I emphasize a lot, and a lot of developers don't understand it. Even cybersecurity people I've met say that, like, what, zero trust exists? And I'm like, well, there's a few people that actually debated that model and had proven that that zero trust model can't exist. This is because when we think about zero trust, we're thinking about completely not trusting anything. When we implement system designs like this, we're relying on old protocol standards or something that was designed by somebody else without an extra forethought of where the trust is in that. So not only does that come from the design perspective, but the business perspective as well. How much are we going to really put into trusting a third party? Because even if you say, no, we're not going to trust the third party and you go build your own tools, you still have to build a tool using a programming language built by someone else. So when you really break it down to it, if there's a vulnerability in any of those systems you rely on, it's going to be an issue. So unless you're like Apple and you're building your own hardware here and you're building your own RFCs and standards from scratch, it's kind of impossible to stay away from zero trust. Even then, it's very, very limited in its spectrum of what true zero trust is. There's a whole philosophical debate about it. You can go on YouTube. I didn't resource it here, but there's a few YouTube videos I did find, which I wish I linked here, but that they debated that topic, and it was a very long debate. So yeah, that's pretty much the end of the presentation. Thank you, South Florida, Southwest Florida Security for having me here and inviting me here. Silicon, thank you for having me here again. And yeah, that's pretty much. Any other questions I can answer? So yeah, yeah, I wrote another version of it in Go because the original implementation needed to be in Go because Go is a way more suited language than mine was at the time, and I used that as an experimental ground to understand the like what I was going to be doing with the file formats and stuff, and what I needed to implement in my own programming language first to advance to that sector. I'm probably going to be sticking with Go for a little bit. I mean, my code auditing and stuff has me on JavaScript, but at the same time, for programming and tooling development, I primarily stick with Go for Linux. C++ is Windows because those two languages are probably my favorite languages as far as what you can interface with network drivers and commands and a whole bunch of other things on the system that are a little bit low level. Plus, it makes things like this heavy task fast. Yeah. So, yeah. Yeah, way faster, especially if you're doing it on a large network. One of the examples I had brought up in the vulnerability was like, or not the vulnerability, but the flaw in the design was that, say you're in a hotel room, and a lot of hotels here, especially in the US, like deal with Roku. Imagine scanning those entire networks and just telling everybody's device to shut down at once, all at the same time. You have to count for performance, and that's also where I came up with Skyline, was because I needed a language that was performant, even though Python has its very, very amazing form of performance, is still very laggy in scenarios like that where the environment is larger. Thank you. Yeah, yeah. I'm trying to make it. I'm trying to work on a few designs. The original system was like that they were going to make like a hybrid programming language that works both switches based on bytecode compilers and machine code compilers. But I felt that optimization in bytecode compilers was way more important considering the time frame, and prioritizing that and prioritizing the compiler itself was like what makes it fast. If the compiler is not fast and the issues aren't right, then it becomes problematic. But yeah, the design was definitely meant to beat Python, in which a few test scenarios did. The reason I haven't released it though is because there's a lot of proprietary zero days and a lot of things in there that I implement that works in my daily life that I can't release to the public for a lot of reasons. I am working on it, but it's kind of it's an ethical barrier. So yeah, what's up? You in the back? No, I usually I don't like using artificial intelligence. I have a few times, like on engagements and stuff, especially messing around with ChatGPT when it came around. But I felt that having an extra artificial intelligence like there would open my research up to way more contradictions and paradoxes that I'd have to iron out later, especially with the sufficient bias in like ChatGPT's model and a few other LLMs that are out there that could conflict with that. Yeah. Yeah, I mean, it's a pretty, it's considerably a high level language. I mean, if you're looking at like C level, C's is a little bit more complex, but Go definitely has its own unique system that's a little bit of a curveball to get around, and it can be a little bit like weird, but I find it's a lot more well-rounded than C because C is a little bit more messy with its code base and the way it implements loops and things are just weird. Plus, the reason why I also developed Skyline was because Python has its thing called global interpreter lock, which is a huge, huge threading issue in C99. So that was like my thing was like, well, Go doesn't have that issue, and that's why it's fast, is because it can multi-thread processes, and it's the same thing I implemented in my own language, multi-threading on the processing of the text and the rendering of the data. So that's kind of that model. But yeah, to sum up, Go is a little bit more higher construct, a little bit more richer in its syntax than C is. So yeah, uh, that's a huge debate. I've kind of spent some time debating that myself, and I spent a lot of time testing it. But a lot of my test cases are very specific, so I find that if I'm going to use Rust, it's going to be something for like really high performance tasks. For example, if I'm working on the Solana blockchain, which they build programs based on Rust, then I'll be using Rust because it's a little bit more faster and performant, and plus it's supported, and it's more better than C as far as what it does on that technological implementation. But during the battling behind the two, I kind of found it depends on your use case. If you're developing drivers, C. If you're developing, cloud infrastructure, Go, because it's a lot more faster and built with network. And plus, Google had their own protocols that they use to implement in the language. Yeah. Any others?